Hello guys, this is Dr. Bandy. I am here to give you my opening thoughts on knowledge management. That's chapter 10. And your book has definitely assembled a nice set of sections and subsections in knowledge management. So I'm not necessarily going to cover the content that you anyway have it available. Let me try to orient you from a little different perspective here. Okay, now this is something very small here, but I've written something. You should be able to see it. I write data to information to knowledge to wisdom. And what do I mean? Now, when we talk about information systems and information and technology, information and communication technologies, ICT, something that's very important for us, you already know, that's data. Now, sometimes I see that there's this confusion. What's data? What's information? And what's the difference between knowledge and wisdom and things like that? So right now, let me just tell you what's data and information, and then as you go through your chapter, you certainly understand what's knowledge, and then we'll also touch a little bit on what's wisdom. Now, data is something that data is the record of events that happen in your business processes. So as you execute business processes, certain events happen. For example, a sales happens. And data is created when a sales happens. So what is data? When sales happens, some values of some important attributes become important to you. For example, at what price, at what location. So the attributes of location and price become important for you to capture given a sale, and the values that you capture for those two attributes create the data for the sale. Now you get the idea. As such, data are simple hard values of those attributes, and they are not much. They cannot be used as such by human beings for decision-making purposes or running businesses or executive business processes. What we need to do is we convert this into information. Information is summarized, collated, and a little bit processed data. A very simple and useful example is, think about a spreadsheet. You have the top row where you have written the name of the column or the attribute, what it means. So if it is age, after that you have different age, 27, 29, 29, 52, things like that. By just putting those first row, you have created a set of information that is valuable. And the next column may be income, the next column may be location or residence, things like that. However, just understand that if you remove the first row of that spreadsheet, you'll have a lot of numbers. The values of the attribute that you covered, pure numbers. But in absence of the first top row, they will really mean nothing. They'll convey no information to you. That's the difference between data and information. We categorize, we collate, we summarize, we understand them in those perspectives. Now, when you have different types of information and you're able to utilize this set of information across different business processes, we say that you have knowledge. And this chapter is about knowledge management, meaning how we use information that start as data that you collect from maybe your SAP systems, how you collate them, create your informations, and how this information actually can be transported across different business processes and create overall understanding and management of those processes. That's knowledge. Now you can understand that knowledge management is very important for us. Why? Because our economy is fundamentally an information economy. 37% of our labor force is knowledge and information workers, meaning we deal with data, information, and knowledge. And about half of our GDP is actually coming from knowledge and information sectors. no doubt that it's very important for us. The other important thing is businesses have shown that if you could execute a knowledge-based project well, ROIs can be very, very high. And as you go through the pages of your book, you will see what are the processes, different processes through which companies collect, assimilate, disseminate, process, and utilize this information. Now, there are some dimensions of knowledge that becomes important. What are those some dimensions? First, it's intangible. So it is not something that you can touch. You can possibly understand the palpability of it in the way other parameters are maintained, but you cannot directly touch or feel. The second important point is you cannot have knowledge just because you have data and information. You require other organizational resources. It could be training. It could be other business process trainings. It could be other domain knowledges that must be utilized in order for the data and information to transport and utilize into business processes to create value. So organizational resources are covered. And third, as knowledge as an asset is shared, it experiences network effect. And if you listen to my lecture on chapter 7, I discussed about network effect. The more people become knowledgeable, another person joining the network of these knowledgeable people gets access to a higher total base of knowledge. In other words, a bigger network feeds higher value to every person who is in the network. So, creating knowledge and creating large networks of knowledgeable people and resources is a very, very good idea. Now, knowledge can have different forms. It can be explicit. You may be able to document it, or it could be tacit, meaning it can reside in a specialist's head. It can reside in a technician's understanding of exactly which steps he or she should follow in order to achieve an optimal result. And that can change as the place changes, as the time changes. The same technician doesn't follow the same steps if it is daytime or it is evening time, or if it is summertime or it is winter time. They may follow different steps. Those are knowledge, and typically it can be difficult to write those. For example, know-how, craft, skill, this could be quite tacit. Following procedure. Laying out procedure can be explicit, but exactly how you follow procedure, especially in difficult situations, often remain tacit into the people who have been experienced in doing so. And then understanding causality, knowing why things happen. So these are typically 4 different types of knowledge that are useful, can be learned, and made to great use in business processes. All right. Now, knowledge is a location. It's a cognitive event. When a physical event happens, our cognition distills and intakes higher level of information and the interrelatability of those information into our mind. That is knowledge. Knowledge is also situational. So it is conditional, it is contextual. Just because you have a knowledge is not enough. You have to exactly know how to apply, or when to apply. And it's also contextual, knowing circumstances to use certain tool. So knowledge may appear to be something very simple, but having knowledge is not enough. Knowing business processes, knowing and having the domain knowledge, and knowing exactly which knowledge elements are to be assembled and implemented in a given set of business processes is a lot higher order capability. But once a person or personnel in an organization can do it, it can create great value. Finally, we are here with the word wisdom. This is a collective and individual experience of applying knowledge to solve problems. So when we talk about wisdom, we talk about, for example, wisdom of the board or wisdom of the VPs of this company. So it is a collective understanding, collective knowledge of several different resources together that creates the wisdom, where time plays a factor, different domains play a factor, different business processes remain factors, where environment and internal business processes and their interplay remain factors. All these, when they come together, it creates wisdom, and wisdom is typically the highest level of understanding that a company has. And one thing I would like you to know, that knowledge and wisdom are very difficult for others to copy and emulate. They can see the artifacts of improvement. They can see the artifacts of better processes that you achieve, but it is very difficult to exactly figure out the level of knowledge or exact knowledge that creates those artifacts. And that's where bigger, better companies are always ahead of their competition. Now, lastly, I wanted to talk about a little bit about 3 different types of knowledge management systems. Your book talks a lot about the enterprise-wide knowledge management system, but there are other 2 different types of knowledge management systems that we increasingly see. That's the knowledge work systems and the intelligence systems. And we are increasingly seeing these intelligence systems more and more into the business processes as being implied and applied by the technicians and by decision managers. Now, for the knowledge work system, these are specialized workstations and systems that enable scientists, engineers, or other knowledge workers. For example, MIS graduates can often, for example, use virtual reality to understand market conditions. For example, in our calls, we have investment workstations where you can work on pseudo investments and hone your skill to invest money in the real stock exchange and create scenarios and then analyze those scenarios, and understanding from those scenarios can then be transported into the real market. Then there are intelligent techniques, and there are lots of different intelligent techniques that you hear. For example, data mining, you've heard about it, neural networks, expert systems, case-based reasoning, fuzzy logic, genetic algorithms, intelligent agents. I will talk about just a few, which I think are more important for business students. The first of those is case-based reasoning, or known as CBR. In many modern companies, these are utilized. What it does is it sort of understands and replicates past experiences of human specialists. And they codify that, these systems would codify that into a knowledge base. And so when a new problem appears, the system searches for cases which are close to that. And with the help of a set of question-answer sessions, it tries to figure out the difference or the distance between the case that's already in the repository and the new case at hand, and solves the difference and connects it to the solution of the earlier repository of the case. So here is what happens. The user describes the problem. The system searches and finds a similar case. Then the system figures out the difference between the case that it has searched from the repository and the new case that has been presented by the user. It looks at the difference. What we say is that it finds out the difference at different dimensions, and then it creates questions for each of those dimensions and pose those questions to the user. And as the user answers those questions, the database searches, researches, and hones its search and finds out the closest fit and retrieves solution and suggests what moderations or modifications should happen on this given solution for the context and the new case that has been brought up. So you see, this is the standard flowchart. So what happens is, as a solution is given, the user takes it to the market or to the business process, implies it, applies it, and this creates a feedback loop. And once this feedback comes in, a more sophisticated search database is created. So this database is continuously augmented as it supports it. So in other words, you start with few cases, but over time you have more and more cases, and searching a case to find a close match becomes easier and simpler when you eventually let the database learn and create a larger set of cases. That is case-based reasoning, CBR, quite important for business scenarios. The other thing that you possibly will see what's known as intelligent techniques. And in this, intelligent agents is something that we often see. Something you possibly have already seen, deleting junk email. You have intelligent agent which can analyze behavior, for example, which emails you delete, and can continuously learn and automatically delete after it has followed this or seen the same behavior several times. Now, I have a small diagram here. It's very interesting. And that also happens to be the last slide that I want to talk about. This is a standard way that Procter & Gamble utilizes their supply chain, purchase, and logistics. They have intelligent agents, and these intelligent agents are coded in a way which replicates actual agents' behavior. So it's something like case-based. So given a case, the agent automatically searches and sees which supplier should provide which material, and then that material should be then forwarded to which retail store. And as a mistake happens or as a problem happens, it goes back and corrects itself and automatically learns and relearns it. This learning process is continuous. And you can understand that Procter & Gamble sells small value items in millions and millions of numbers. And so they have to maintain a great, expansive, and extended supply chain network. And it must be in the finest tune. It must be finely tuned in a manner that there is no lost sales or purchases are never done in a suboptimal manner. And having human agents working across this, typically when you have a network across the world, it's quite difficult. So this is an improvement and utilization of intelligent automated agents in P&G's supply chain network. Now, I guess I have given you enough orientation about what is knowledge management, how we should look at it, how they're situational, how they're contextual, how they get or begets value for us, and what are the more modern ways that businesses are trying to utilize technological support in order to create, manage, disseminate, and utilize agents with the help of these knowledge and automate processes and manage their networks in a bigger and better fashion. Thank you.